Good morning, everybody, and thank you so much for joining us for today's webinar, Solar Carports, Designing Tomorrow's Energy Generating Spaces. My name's Claire. I'm the Deputy Registrar at the OAA, and we will begin today's webinar by acknowledging the land on which we are meeting and calling in from. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. So before we begin, I do want to give you some important information so that we have an effective and professional webinar experience today. Do note that we are recording today's session for quality and educational purposes. To have a stable internet connection, we've muted all participant microphones and disabled your video feeds. But we really encourage you to engage through the Q&A window. So you'll see there's a button at the bottom of your screen. At any point during the presentation, if there's a question that comes to mind, please put it in the Q&A. We'll have a designated about a half an hour at the end of the presentation to go through those questions. So please do, as they come up, please write those down. For those of you here on the call who do seek continuing education learning hours, you will have to attend at least 80% of the session to be accredited those hours. And we will be uploading those hours and processing them. Just allow us for a week or so to do that. We have provided closed captioning services available in multiple languages. And lastly, note that our presenters don't provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in the discussions during the webinar. So with that being said, I am very excited to introduce today's speakers. Please welcome Patrick Boot and Brian Unrau. And I'm sorry if I've mispronounced that, but welcome both. Okay, great. Thank you.
Thanks, Claire. And hi, everyone. We're really grateful to be here. We'll do some intros, some deeper intros in a couple slides here in a second. But yeah, just thanks for joining and giving us some of your attention today. We really enjoy these sessions. Over the past few years, we've been able to share our ever-evolving and growing carport industry knowledge, solar carport industry knowledge in sessions like this, but also in-person lunch and learn style kind of engagement sessions. We've done a handful with architectural and engineering firms in the greater Kitchener-Waterloo area. We're based in Kitchener, but do projects all across southern Ontario. But yeah, we're happy to sort of cast a wider net and broader net in terms of geographic audience. Not sure everybody's joining from, but yeah, excited to be here. We're firm believers that sort of sharing information, stories from the field, challenges, emerging technologies, and best practices is the best way to set up future canopy projects, future carport projects for success. So there's lots to consider in these projects and in the solar industry more broadly. Happy to kind of field those kinds of questions as well if there are some. We definitely have enough content for multiple sessions, but we'll try to hopefully share a relevant overview for you all today. So again, just in terms of a session overview, we'll explore the Ontario solar carport and canopy industry, including technologies, typologies, design challenges, lessons from the field. We've kind of grouped things into these three rough chapters. So making sunlight structural, from dead space to design feature, where we'll really talk about typologies, models, site integration, that kind of thing. And then the third, hidden grids and the codes that shape them. So really the coordination and factors that need to be considered between architects and engineers. So things like structural loads and zoning and those kinds of things. And throughout the whole presentation, we'll kind of sprinkle in some case studies and stories from our construction projects in the past, and also things that are, very much in live construction. I think our most up-to-date picture was taken yesterday on site in Cambridge. So you are seeing some real life projects happening. We'll just start things off with a couple of poll questions. So we'll start with question one. If I think it's Shalika or whoever on the OAA side can throw that one up. So, what's your experience level integrating solar of any kind? Rooftop, ground mount, canopy, BIPV, or building integrated into a project? Curious what yeah, just sort of get a lay of the land, so to speak, of who our audience is here. I just tried to vote, but then I see the red text at the bottom that says hosts and panelists can't vote. So we'll wait for the results. Okay, interesting. So we're seeing the results. I imagine everyone else can, but it looks like 32% say none. So 16 of 50 guests on the call. That's great. About half of you, 50% minimal, and then it kind of trails off from there. So kind of what we thought. Obviously this is our bread and butter. We're in this every day. So we've tried to not be too, industry jargony, and recognizing that the level of interaction with this stuff of a more broader audience is a bit less. So hopefully it's aligned accordingly. Yeah. Okay. Moving on. So the learning goals, by the end of the session, we're really striving to set you all up with the information to help you, one, understand how solar carports can contribute to architectural form, not just function, to compare solar carport typologies and their integration within specifically the Ontario built environment, identify structural and code coordination points, again, critical to that local Ontario environment, and then apply strategies from built case studies that think more broadly about aspects of resilience and aesthetics and technology that are relevant in solar canopies. So again, another poll question, just to do another bit of a gut check, but specifically, so for those of you that do have some experience, what percentage of your buildings or projects would you say have solar as an important design element or consideration? How often does solar tend to come up or be part of projects that you work on? And then I promise we'll stop with questions and we'll get into the content. Okay, pretty low. About 55% of the call is 5% or less. Between 5 and 10% of projects for about a third of you on the call. And then, I mean, there are two people on the call that we probably want to talk to, because 50% or more of their projects have solar in some way. So interesting. I would say, Brian, what do you think? Like unfortunately, it's low, but I think it's predictable what I would have anticipated. How about you?
Yeah, I mean, it seems to, if you look across the landscape and see how many sites you actually see solar panels on, this tends to align with that. So it's not totally surprising.
Yeah, great. And hopefully, insightful for you in terms of the audience of the other audience members, kind of where we're sitting in terms of solar dissemination across projects in the stuff you're working on. Okay, so yeah, a little bit of background before I dive into content. My name is Patrick Boot. I lead the products division here at VCT. So VCT Group is a Canadian firm focused on solar energy systems for commercial and institutional applications. My background's in industrial design. I studied industrial design at Carleton, graduated back in 2009. And I try to bring a human-centered design, a design-rooted perspective to VCT's product development. So trying to value both technical performance and contextual fit, understanding usability and those kinds of things. So currently my work is really focused here on solar carports as infrastructure that kind of brings new life to underutilized spaces and really surface parking lots. We will kind of use carports and canopies as interchangeable language in this presentation. The distinction for us obviously is a canopy that's over cars is a carport, but these structures aren't necessarily limited to only being carports. There can be sort of covered entertainment areas or agriculture areas or those kinds of things. Solar canopies have more broad application than just carports, but we'll use those terms interchangeably. And I'll pass things off to Brian to introduce himself and then dive into slides.
So I'm Brian Unrau. I'm the president of VCT Group. And as Patrick relayed, we specialize in integrating solar energy systems with the built environment. My background includes a Bachelor of Environmental Design from the Faculty of Architecture at the University of Manitoba, an MBA from Wilfrid Laurier, and I'm also a chartered professional accountant. Over the past 15 years, I've led the design, engineering, and construction of solar PV systems across many contexts, from commercial rooftops and solar facades to ground-mounted arrays and what I believe are architecturally expressive carports. At VCT, I lead a multidisciplinary team that has delivered hundreds of solar projects across the province. We handle every stage of the process, contract origination, environmental approvals, design, permitting, procurement, construction, and commissioning. Because I've also been an owner and operator of many of these systems, I bring a long-term performance-driven mindset to each project. At the core of my work is a deep commitment to building integrated sustainability. I aim to blend architectural sensitivity with technical performance, and whether that's through innovative solar canopy systems or high-performing rooftop arrays. I'm dedicated to helping buildings play a meaningful role in shaping our low-carbon future. So we'll start with making sunlight structural. We will be sharing a copy of this presentation in PDF format with the OAA to make available to people who have joined the session today, so you will have these materials as reference. So starting with our story here, when we first got into solar back in 2009, carports weren't even on our radar. We started with dual axis trackers, which are ground mounted machines and motors and gears that tilt and rotate to follow the sun across the sky. From morning to night, they chased every ray of light. We installed hundreds of them, and at the time they made a lot of sense. We liked them for their intelligence, squeezing more energy out of each panel. We thought, this is solar done smart. However, fast forward to 2017, and we got the opportunity to work on the Evolve 1 project in Waterloo. And this was Canada's first certified zero carbon building from the Canadian Green Building Council. Now, even then, we were still tracker people, so naturally we tried to convince the property owner to install a field of trackers in the parking lot. He shook his head and said, no, carports. We begrudgingly agreed, and I'm grateful we were nudged, because during that project, I think I fell in love with carports. So before we dove headlong into the carport design, we validated the opportunity. Parking lots are one of the last great underutilized canvases in our cities. In Canada alone, we have about 80 million parking spots, and a full quarter of those, roughly 120,000 acres worth of asphalt, or 40 million spots, are in the institutional, commercial, and industrial sector, which is bigger than some provinces. And here's the kicker: per capita vehicle ownership is still climbing. Households with 3 or more cars are growing fastest. So we see parking lots as a necessary evil, but something that is going to persist into the future. They aren't going away. In fact, they're growing, which means we have to ask, will they remain heat islands of asphalt, or can they become power plants and public assets? So everyone I've ever taken for a stroll under a carport has had a similar reaction. Basically, they stand underneath, look up, and say, we need to do this everywhere. And I'm hoping you all start to feel the same. We think it just makes sense. It's solar you can actually stand under. It's not invisible on a rooftop, but it's part of our daily life. It's shade, it's shelter, it's identity, along with clean energy. And here's the real architectural shift. Rooftop solar really just asks the technical question, how many modules can we squeeze in? Carports ask a very different one. How can structure and energy elevate the space? And that's where solar stops being equipment and becomes architecture, we believe. The first carport we built was supplied by a company called Schletter. Halfway through, they filed for bankruptcy protection and everything froze. Some of their former staff, even unpaid at the time, helped us work directly with the aluminum extruders, and with their blessing, we managed to finish the project on time and on budget. The only thing we lost were a few sleepless nights. Unfortunately, when Schlitter came back out of bankruptcy, they stopped selling carports altogether. So there we were. We just built our first carport. We were getting compliments left and right. We saw the opportunity in front of us, and suddenly there was no product to buy. And that's when we made the decision, if we want to keep building these, we'll have to design our own. So what began as a reluctant yes became a design commitment and something that we've now been working on for about 8 years. Now, I'd love to tell you that our first design went up flawlessly, but it didn't. We went back to the drawing board more than once on the foundation layout, trying to balance structural spacing with vehicle alignment. We mocked up door swings and clearances. And honestly, what we ended up building, I think, is really only barely acceptable. And then came installation. The original design used clamps that pulled from the top, which meant our crews were tempted to climb out of the lifts to reach them. Not exactly safe. We'll just have to say that our safety officer was kept busy during that installation. And then the first winter hit. Suddenly, we had 3-foot icicles dangling throughout the entire array. One person described to us that he was ending up scraping 3 inches of ice off his windshield before he could drive away. And so that really wasn't the user experience that we were hoping for as we built these systems in the parking lot. Snow would drop right at the edge of the stalls, and it was close enough that plows couldn't clear it properly and cars couldn't get out of their parking spots. Was a humbling reminder, getting the design right isn't just about structural integrity or panel yield, it's about how people actually use this space, and that really informed how we looked at things going forward. Carports are exposed, they can't hide, they demand architectural consideration, there's the rhythm, the proportion, and its physical presence. And at the same time, snow loads, drainage, budgets, maintenance, it's a balance of beauty and pragmatism, and that's what makes them a fascinating design challenge. So out of those early lessons, the door clearance issues, the safety headaches, the snow and ice disasters, we started to shape our own design priorities. And if you embark on your own design of your own carport or canopy structures, or simply looking to the industry to see what features of a carport are important, we recommend consideration of the following. Firstly, no vehicle obstruction. It seems obvious, but parking stalls only work if people can actually open their doors and get out safely. Second, using industry standard panels, but build in flexibility. So module sizes right now are a moving target in the industry. They're getting larger every year. So we feel that a good carport needs to adapt as panels evolve without forcing a redesign every few years. And as a specialized product, there are what we call frameless modules available in the market that are more similar to an insulated glazing unit. We looked at these for the basis of designs, but realized that it didn't make sense for us to pay a premium. Sometimes those cost up to 5 to 10 times the cost of a regular panel. And then the first thing we want to do is put a metal frame around it. So we went back to the industry standard panel and decided that that's got to be our basis. Third, we wanted to optimize for bifacial panels. So there's free energy bouncing off the pavement that can hit the backside of the panels, and we want to capture it. So depending on the site and the elevation of the plane of panels, we can produce an additional 10 to 15% more energy using bifacial panels, and these panels are more or less the same cost as a single-sided panel. Managing water and ice, for sure. So no more free 3-foot icicles, water should be channeled, snow should be handled safely and predictably without any liability. Construction matters. So we have to design something that's safe and efficient to build. We've really focused on the efficiency of building our systems. No one should have to climb out of a lift to just tighten bolts. So we've managed to devise systems that everything can be handled from the underside. Another thing is aesthetics and finishes. These are highly visible structures. They need to look good on day one, as well as 30 years down the road. And so that's what led us for a lot of our designs to look at aluminum. Well, there's some other good options in the material selection that Patrick's going to cover. Various integrations. So EV charging, lighting, sensors, cameras. Carport's the perfect platform, but it has to be designed to accept those elements seamlessly and really make them look like they fit with the whole structure. Cable management, of course, is very important as well. We need to keep it secure. There's a lot of cable thieves out there, as we see regularly on some projects. We need to keep it clean, and wherever possible, we want that cabling to be as invisible as possible as well. And then finally, electrical bonding or grounding. It's not glamorous, but it's essential. A carport is a piece of architecture, but it's also an electrical system. So we have to manage that as well as safety comes first. So taken together, these became the core of our design checklist, our way of turning those early growing pains into a system that was not just functional, but durable, safe, and we hope worthy of being called architecture. So a little bit about some of those individually. So one of the biggest advances in solar technology over the past few years is the rise of bifacial panels. Unlike traditional modules, bifacial panels collect sunlight not just from the front, but also the backside, capturing reflected light from the ground or snow or surrounding surfaces. And in the right conditions can add 5, 10, or even 15% more energy production. But there's a catch to that it only works if the back of the panel is actually exposed. If a beam or conduit shades the backside, you've essentially paid for a window and covered it with plywood. So good carport design means keeping the backside clear and uncluttered. Structural members need to frame the panels and not eclipse them. And of course, cable management and electrical bonding need to be tidy and not draped around. Done right, we think bifacial optimization is about turning every square meter of the canopy into a working surface, top and bottom. It's a detail that looks small, but we think it can add years of extra energy yield over the life of the project and really improve the economics. Another thing that we see out in the industry is that not every so-called solar carport we believe is really a solar carport. Too often what we see is just generic frames with a deck on top and then solar's really just bolted to that. Really, they just created a roof and they've done rooftop solar out in that parking lot. The panels are incidental and sometimes they're even invisible. So we think carports are the opportunity to make solar authentic into the design. The panels aren't really an accessory, they're the roof plane of the system. The structure, the spans, the rhythm of light, all of it shaped together with solar in mind. So it's really taking it from a carport of solar, not merely a carport with solar. And that's when they stop being shelters and become symbols of value. They're really statements of climate leadership. As one person put it, it is often the first and last impression you have of a facility when you arrive or depart. And we think it leads to better architecture. Textbooks will tell you the optimal slope is about the latitude that you're located at minus about 10 or 15 degrees. So here we are in Waterloo region at the 43rd parallel. So that would put optimal orientation or optimal tilt at about 30 degrees. But a 30-degree carport is kind of impractical. It's kind of bulky, awkward, and it almost looks like we put a ski jump in the parking lot. So we compromise. Most carports we build and what others build in the industry are somewhere around a 10-degree slope. And of course, you want to try and have that due south wherever you can. Taking it down to 10 degrees from 30 degrees in our area here is a bit of a sacrifice, but it's only about 5% of the energy generation by taking it down those 20 degrees. And if we take it off of due south and start turning it either east or west at a 5-degree angle off of due south, you want about a 5 to 10 degree slope on things, and we're only losing about 2% more power. So it isn't so critical that everything has to be exactly true south when you're looking at orienting things in a parking lot. And then if you even get so far as facing due east or due west, then actually 3 to 5 degrees is optimal, and you're losing another 4 or 5% production. But sometimes it's just necessary to work with the drive aisles. And then the good news is that the bifacial gains that I was mentioning can help claw back most of what you lose from not chasing textbook perfection. So the sweet spot is really just balancing that energy yield, the structure, the aesthetics, and how you're going to work with the snow. Solar panels are long-term assets. They have no moving parts within them, and most of them carry a 30 to 40-year production warranty. But the warranties assume proper care. The panels rarely fail because the silicon wears out. What often happens is that they fail because of micro cracks, and that is caused by stress or torsion or point loading on the panels. And ironically, the most common cause is not the weather, but in fact, the people that install and service the system. So stepping or kneeling on panels during that install or service is really what's going to cause a lot of the damage to a system. So we think that part of carport design is protecting panels not just from nature, but from us ourselves. And that's how we believe we get long-term value. So here's a little video produced by the National Renewable Energy Laboratory that shows what happens to a panel, or pardon me, a cell inside a panel. Hopefully the streaming of this works effectively. We can send a link out to watch it through YouTube at another point.
It's not really working. I can see it on my screen, obviously, but I don't really know how that translates out there.
Okay, so effectively what's on the screen is electroluminescent. So as much as we mostly shine light on a panel and then get electricity out of it, you can actually operate a panel in reverse, apply current to it, and it becomes a bit of an emitter of infrared light. And so when you do that in a darkened room, you can see what parts of a panel yeah, there isn't any sound to the video. It is just a silent video, but you can actually see through that light production what parts of the panel are still active, and anything that's darkened is a part that's now broken away from the electrical system and is not able to continue to produce power into the system. So as we saw, inside each panel, there are cells, and those cells are wired in strings. So the ones we use today, there's typically 3 or 6 strings within a specific panel, and within each string, the cells are connected in series. And if you remember your, what would it be, grade 10 science or physics, series means the weakest link rule. So if one cell underperforms, the entire string is dragged down to that level. It's just like the old Christmas lights. If one bulb went out, the whole string went dark, and that's the same idea here. So for a panel with 3 strings, shading or the breakage of a single cell can drop the panel's output by 1/3 down to about 67%. And if an entire row of cells is shaded or fractured, but they're all in the same string, it doesn't change the impact. It's still the same, you lose 1/3. Now take that breakage or that shading, if it's across a set of cells that have all the strings within it, the whole panel can actually go to 0. And so that's why shading or cell damage is really the enemy of solar. And that's why design decisions, how trees or light standards are placed around the canopies and how you place the canopies in relation to the surrounding buildings is really quite important. There are bypass diodes that are built into panels to reduce the impact, so one bad panel doesn't cripple an entire string, but even then, some performance loss carries through the string, and that's typically anywhere from 10 to 20 panels in that string that are now producing less. So our takeaway here is that in solar design, little things can have really magnified effects on the overall performance of the system, so we need to pay attention to these details. You perhaps heard the concern, aren't solar panels too glary? Should we be keeping them away from sensitive sites like airports? Well, here's the backstory. The FAA once tested this using a glare simulation device. Quite literally, a 50-watt halogen bulb pointed directly into the eyes of a test subject from just a short distance away. The picture top right is actually taken from that FAA study. And not surprisingly, the conclusion was solar panels could impair pilots. But that's not a panel. The reality is that reflected light is lost energy. Manufacturers have every incentive to minimize reflection, which is why there's been significant investment in anti-reflective coatings on the glass. And in fact, modern solar panels produce far less glare than windows or even car windshields, and you see plenty of those around airports. And messages getting out on the bottom left, you see the Tucson International Airport. So unless you're planning to ban buildings with windows, or solar glare is not something that we need to lose sleep over. In terms of the business model of how do you integrate and get the value of solar on a site, the backbone economic model in Ontario for solar is something called net metering. And here's how it works on the slide here. So the solar system, whether it's located on a rooftop or in a parking lot, is connected right into the main building service behind the meter for the site. And so if you're producing, and when it generates power, you use the power and energy on site first. And if you're producing more than you need in any given moment, that excess then flows out to the grid, and it effectively spins your meter backwards. And then for every kilowatt hour you export, you get a credit on your utility bill. Later, when you need more power than your system is producing, so say in the evening or cloudy days, you pull that electricity credit back from the grid and the credits are applied. At the end of the billing cycle, you're only charged for your net usage. That's where the net of the net metering term comes from. So you pay for your net usage, and any credit surplus can be carried forward and used up in future months. So in practice, your parking lot canopy becomes both a generator and a buffer. When the sun is out, you're making clean energy. When it isn't, you're drawing from the grid. But on a credit system, it smooths that out over time. So for clients, this means predictability. They're not just offsetting power in vague environmental senses. They're really literally reducing their bills. And as we mentioned, bills, reading and interpreting electrical bills is really a dark art in Ontario. They are some of the most confusing documents I think a person could ever try to interpret. So if you're ever looking at electrical information and want some help, by all means, reach out to us, and we're happy to provide some guidance on this. But again, here's where it ties to architecture. The bigger the canopy, the more surface area you dedicate to generation, the better the economics. We get significant economies of scale. So a large system is going to have much better economics than a small system. And then, of course, the parking lot decisions, stall counts, layout, canopy span, they all directly affect not just form and function, but the financial return. And the carports don't just pay back through electricity and carbon offsets. They really change the economics on a site in ways that go far beyond the meter. So they can reduce ongoing operating costs, they can lower maintenance, they can extend the lifespan of existing infrastructure, and even create new revenue streams. In some cases, these side benefits are just as compelling as the energy itself, and sometimes even more so. What makes solar carports exciting is to stack all these values together in a single piece of infrastructure. So instead of selling one story, this saves energy, you're offering 5 or 6 different stories of financial and functional return. One of the biggest hidden costs for property owners over the next decade will be EV charging infrastructure. And done poorly, it means tearing up parking lots and trenching new conduit and redoing civil work every time demand grows. But done well, it means planning ahead. And with a solar carport, much of the infrastructure is already in place. The conduits, the switchgear, the layout. EV chargers can typically be added incrementally as demand increases without ever touching the pavement again. And that alone can cut future installation costs nearly in half. Then there's snow clearing. Anyone who has run a large parking lot knows it's an ongoing headache. By covering major sections with carports, you reduce the acreage that has to be plowed. You also make it possible to clear snow more efficiently, even during the day when vehicles are parked. So instead of waiting until night or shutting down sections of the lot, you can facilitate a cleaner parking lot throughout the days. And let's not forget water. A flat lot sheds water in unpredictable ways, but a carport roof gives you a defined plane, which means you can capture water at the source, clean, concentrated, and ready to use. So that can be fed into irrigation cisterns, or feed irrigation or into cisterns, and then be used for gray water flushing systems. So it's not just cost savings, it's resource efficiency along with it. On the topic of maintenance and safety, one of the biggest recurring costs in Canada is parking lot salt. Tons and tons of it is spread every winter, but salt is corrosive. It eats into concrete, into the asphalt, into the curbs, and even into the cars themselves. And so with solar canopies, managing water and snow properly, the need for salt is drastically reduced. By channeling runoff in controlled ways and preventing ice sheets from forming in the first place, you create a lot that's safer to walk and drive on without the annual expense and without the environmental damage that salt runoff causes to landscapes and stormwater systems. This also feeds back into maintenance savings. Less salt means less damage to asphalt. Less damage means fewer freeze-thaw cracks and fewer resurfacing cycles. And over the lifespan of a parking lot, the difference is enormous. And it's not just dollars, it's liability. Safer surfaces mean fewer slips, fewer falls, and fewer claims. Parking lots are expensive to build and maintain. Plows scrape surfaces. UV accelerates chemical breakdown and degrades asphalt binders. And of course, those freeze-thaw cycles widen those cracks once that begins to happen. And carports reduce nearly all of these. And so less plow area, less salt, fewer freeze-thaw cycles, and shade that protects those binders. You can generally extend a lifespan of a parking lot by an additional 10 or 15 years. And again, for owners, that's millions in avoided costs. And for architects, it's designing infrastructure that preserves itself. And shade is more than just being about comfort. It is also about protection. So if you're thinking about your own car at this time of year, the searing heat, the fading upholstery, the sticky film that builds up on the inside of your windshield. I know I need to clean mine right now. That film is literally your dashboard and your interior plastics off-gassing. And it's the slow destruction of value. So now multiply that across a fleet of vehicles for a company, a dealership, or even a municipal fleet. Keeping vehicles shaded under carports slows UV degradation, it protects their finishes, and it extends their usable life. And that translates directly into higher resale values and lower replacement costs. And in some regions, it's not just sun, but hail. In hail-prone areas, many dealerships can't even get insurance for their lots anymore. And so solar panels, on the other hand, are made of heat-tempered glass, typically rated to withstand a 25 millimeter hailstone at terminal velocity, which is about 83 kilometers an hour. And some are even rated to handle 35 millimeter hailstones. And panels survive hail far better than vehicles. If one does ever break, the cost of replacing a panel is a couple $100, much less than the cost of replacing that vehicle. So when you look at it that way, the canopy is not just a generator, it's also an insurance policy. And so one of the clearest signals that this is more than a niche idea, that it is really something that's growing, is the policy momentum behind it. In France, parking lots with more than 80 spaces must add solar. If you have more than 400 stalls, it's by July 1st of 2026, which is less than a year away. And if you're between the 80 and the 400 stalls, then by 2028, you need to have canopies in place. And then there's payments that you have to make if you aren't meeting those goals. California recently had Bill 49, which opens highways and rights of way for additional solar and solar canopies. Rhode Island has lots over 16,000 square feet must cover half with canopies, and 5% of stalls must have EV charging. And Maryland has a canopy dual use grant of up to 60 cents per watt, which is about 25% of the system cost. And so the messaging is clear. Government see carports as climate infrastructure, and they're making them mandatory, or if not mandatory, then hopefully irresistible from a cost and payback standpoint. So we believe that the question for us in Canada is not if this comes, it's more of a question of when it's going to come.
Okay, I'm going to dive into the sort of maybe hidden aspects and the codes that shape them, and all the coordination that needs to happen between architects, engineers, designers, construction teams, that kind of thing. So I'll delve into the practical realities of structural loads and appropriate material choices and zoning and all those kinds of things. You know, it really seems like solar and infrastructure more broadly, it really gives no visual or auditory cues that anything is happening. They're sort of these static structures from a visual perspective. So like a lot of design and architectural aspects of our world, when we resolve these things well, they sort of perform these beneficial functions quite stoically. So I'll touch on these code aspects. In the interest of time, I've kind of combined two chapters together. So I'll also touch on the sort of typologies and carport, you know, site integration and that kind of thing. And then we'll wrap up with some Q&A. So there are some realities to factor in when thinking of integrating carport or canopy, solar or not, into site design. You need to have a decent understanding of the forces acting on these large spanning sails in the sky, and ensure that solar canopies you integrate onto the designs of your site are safe and intentional and resilient and consider all of these loads with elegance. So, you know, we're talking about the dead loads from the PV panels and the racking and the electrical equipment, live loads from snow and rain and wind, uplift and lateral wind loads, and then seismic or kind of earthquake loads. All of this is sort of governed by the Ontario Building Code. The Ontario Building Code sort of states that carport and canopy frames and connections need to be designed for local site-specific, you know, so Ontario snow, not even more specific than just the province of Ontario, but as you'll see in kind of this example, this was a carport that we designed and constructed in Scarborough. The study is quite location specific. So although there's plenty of carport as product language in the industry, solar canopy engineering is quite site specific and considers these aspects of our world to sort of resolve these quietly. So working within those not constraints, but those realities, it kind of leads you to three structural building materials. You've got structural metals like steel or aluminum, or like a structural timber or mass timber like a glulam, that kind of thing. So any of these, all of these can be used to create unique, functional, aesthetically pleasing solar canopies that work within and can sort of wrestle with those forces I talked about on the previous slide. So expanding a little bit more on each of those materials, if you're talking about steel, again, you know, many of you may be material scientists to different levels of expertise, but some of the highlights in terms of pros and cons of all of these materials. So strength has, steel has high strength and durability for load bearing. So therefore, it's capable of spanning larger distances between supports, potentially having a lower impact on parking area, although I'll talk about the municipal guidelines a little bit that sort of govern setbacks and things like that in a little bit. With steel, there's typically lower initial cost for the material, high stability, the kind of in terms of deformation resistance, and you're often working with industry standard dimensioned beams. The cons on the other side, challenges with using steel, it's very energy intensive to produce. You have some added fabrication costs, maybe some specialized labor in terms of welding on site and those kinds of things, and then added maintenance costs to prevent corrosion. When it comes to aluminum, obviously, pros are it does also have high strength to weight ratio, or it has a high strength to weight ratio, much better corrosion resistance, an ease of fabrication, or an ability to manipulate complex profiles. Largely, you're extruding large profiles, but the design of the intricacies of those are set in the die, and then you're not sort of stuck with C-channel or I-beams or those typical profiles of steel. There's a faster path to decarbonization, as smelting of aluminum in Canada anyway is fully electrified, with a lot of it coming from hydropower in Quebec and the bauxite mines and the production of the aluminum billet. Some cons or challenges with aluminum: typically higher upfront costs for the material, and requires more frequent support in terms of structural support, not capable of spanning as greater distances as steel would be. Some quick benefits of mass timber, like a glulam product. It does have a high strength to weight ratio. Reduced carbon emissions are actually a carbon sink in that sort of wood fiber material. Faster construction timelines, so we've heard, although we don't build with mass timber ourselves at BCT. Cons and challenges: there's again typically higher initial costs. There's a bit of a susceptibility or vulnerability to moisture without proper sealing and that kind of thing. Maybe some potential acoustic performance limitations, depending on the application. Outdoor for carports, I would think that would be quite minimal. And then from a production standpoint, that need for responsible forest management. So for many of these, from a sustainability standpoint or a material production standpoint, the carbon emissions aren't really inherent in the material themselves. It's really that carbon emissions side or aspect is baked into the production processes. And there are paths to decarbonizing all of these materials. If you look in the right corners of the internet, both steel and aluminum claim to be the most recycled material. I guess the sort of conclusion of this slide was that if you're thinking of like a one-off or custom structure, you're probably going towards steel because of the structural aspects, but also the sort of like readily available stock dimension material. In our experience, aluminum is, there's this sort of inherent repeatability model or philosophy, because you're making use of a stock set of dies that produce the same profiles that you might be combining in different combinations or sub-assemblies to make different shapes and that kind of thing. And then for mass timber, maybe a conclusion is that sort of cantilever members of mass timber get really big really quickly to handle the forces and the loads. So they're really best in post and beam construction, sort of four supported corners, that kind of thing. If I'm thinking sort of like sequentially, so you want to think of the structural loads that are acting in that specific geography in that specific location with adjacent buildings and that kind of thing. The next thing you might want to think about is the fact that, as Brian said, with net metering, all of these systems are grid connected, and so there's some considerations to think about. All of these solar systems, whether it be canopies or rooftop, are in Ontario are largely connected. They're connected to the building's electrical panel, unless you have sort of an off-grid situation where you have a battery backup. But even then, there's coordination and intentionality that needs to happen with the building's electrical panel and ultimately the grid. Brian talked about a lot about net metering. I won't get into it, but it is governed by that Ontario regulation. So you want to, or what's important to think about is that the grid has capacity restrictions and requirements. Some areas of the grid are quite taxed already. Some have plenty of capacity, and so all of these are what are called DERs, distributed energy. What's DER stand for? Distributed energy resources. I was going to say systems or something, but that's not R. So they are energizing, or they're capable of sending all of that energy or sending portions of that energy back to the grid. And so the grid needs to know where their sources are that are pumping energy into it, as much as it knows, how much energy is flowing around in that grid. So you have to complete what are some sort of basic requests and checks. One of them is called a PCIR, preliminary consultation information request, and then ultimately a connection impact assessment. Different LDCs sort of funnel some costs of grid upgrades, I guess, through those connection impact assessments. Some of them are quite low, in the $5,000 range, or even less, and then some are upwards of hundreds of thousands of dollars to actually be allowed to connect this DER, this generation system, this canopy, through the building's electrical panel, leveraging net metering, and then back into the grid. The other thing you'd want to think about at this point is that the solar power electronics, the voltages, all those things need to align with the building's electrical service. So transformers or step down transformers from the grid in that area, space on the switchgear. So from a early planning aspect, you want to make sure architecturally that all of those systems are kind of aligned. So regardless of sort of structural material choice and form factor, these structures need to adhere to Ontario Building Code, really, fire department access, fire lane clearance. So you need to have, fire lanes that are 6 meters wide. You need to have at least a 12-meter sort of inside turning radius around these structures. 5 meters of overhead clearance. So that's important when, sometimes in these canopy structures, as you see on the screen, you'll have perfectly vertical members, but sometimes you have angled members. And if those are kind of coming over top of a drive aisle or something like that, we just, need to be mindful of those kinds of clearances. Those are really important. And then from an accessibility standpoint, AODA or design of public spaces kinds of things. If you construct or redevelop off-street parking, you have to provide accessible spaces at various sort of like minimum percentages based on how many spots there are in the lot. So again, happy to share, or we're going to share this deck afterwards, and we'll sort of make a point of adding the sort of details that are in the slide notes on into some slides as well, so that you have those specifics on, spaces are the sizes and setbacks and the ratios when it comes to accessible spots and minimum numbers and that kind of thing. I've already done that. That is this slide. I forgot that I had added that. So so then different kind of typologies or form factors are designed for specific applications within the context of structural loads, how much the grid can sort of support in that area. But you might look to integrate sort of single row coverage cantilever designs, or larger monoslope in that monoslope design that would sort of cover 2 rows of parking, nose to nose parking, or double loaded as we would call it. So many of these are sort of double loaded form factors. A dual slope with a central trough is if you're thinking about water management and funneling something to a central gutter or something like that. A dual slope or a central ridge sheds that water to the edges of the array. So we're implementing a dual slope central ridge over a sort of picnic area at the equivalent of an amusement park or something. So different applications, different form factors for different use cases, different generation targets, coverage areas. You can get into kind of hybrid, what we call a checkmark design on the bottom left there, that kind of manages both. You get like a big flat plane, but then also a little tilt up so that you can run a gutter in that ridge, and then different sort of combinations of these kinds of form factors. Another thing, or the next thing that you might want to, or is important to think about, especially in canopy applications in parking lots, so carports, solar carports, is sort of zoning and how that zoning and how that needs to be considered with respect to parking geometry. So stall sizes, drive aisle widths, these things are quite standardized, but they do vary. There's some variance. They're similar but not identical from municipality to municipality. So I'll get into a bit of a case study in the next slides that get into this a little bit, but by and large, here's an example of Toronto. So drive aisles need to be 6 meters if you have 90-degree stalls, but if you have angled stalls and you're entering from an angle, then there's some differences. Again, that example's from Toronto, but municipality by municipality, it's important to sort of cross your T's and dot your I's when doing carport design to make sure you're checking those boxes. I'll get into more details about the 4 different visuals after a bit of a case study here. So we did a project, it's not commissioned yet, but completed construction of a sort of single row coverage cantilevered canopy like this. That looks like this is a mock-up of it, but this is in Newmarket, Ontario. So we move forward with the typical kind of architectural and engineering coordination that needs to happen. So we're working with minimum heights and those clearances and everything. The foundations look like sort of an embedded pad and then a pier that sticks up. This would be our typical foundation for a structure like this. The challenge that we ran into was that there was a property line running sort of east to west or side to side across this image, and we couldn't cross that property line underground or at grade. So that meant that foundation that had a large pad with the pier sort of centered within it needed significant rework to work within the local municipal guidelines and where that property line sat. So we ended up having to create a large sort of footer that extended out under the cantilever of the carport to counteract that force that was being shown to would be applied, especially when adding some of the live loads like snow and rain and wind and that kind of thing. So this is on the right is a schematic of what the design ended up looking like, and then a live shot of a sort of in the field of how that looked with the curb integrated right at the back edge, so that we are not encroaching at grade or below grade. We were able to allow them to, or they allowed us to allow the back edge. I'll go back to this slide. The back edge of the canopy to extend over that property line, but nothing at grade or below grade could be extended past it. So pretty proud that we were able to come up with a solution there. But this is just one example of the kinds of localized challenges that any carport designer, installer, construction team, architect is going to need to consider, is that they change from position to position or from geography to geography. So then back to those 4 kind of examples of how you can maybe think about integrating the foundations and the frames within parking lots specifically. So there's kind of this maybe standard layout where you're spacing foundations on parking lot lines or with existing parking lot or parking spot spacing. In our experience, again, I said this earlier, but with aluminum, you're not really spanning more than 2 spots, so about 6.8 meters max from side to side. There's a little bit of variability, again, depending on municipality. Some parking spots are a little bit tighter, but in a sort of standard approach to how do we space frames, this would be the way. If there's either way, you're likely losing a bit of parking, a percentage of parking, because depending on the municipality where they start measuring that parking spot is probably on the inside edge of these foundations, and so you're not actually able to count that distance right to the painted line, because technically the foundation is obstructing a bit of that parking spot. And again, municipality to municipality, there's different rules about that. If you're going to be or if you want to sort of almost in like a bollard style, or like clear delineation between the space taken up by the frames and the foundations and the spots themselves, then sort of what we would call a spread approach with different painted lines is maybe a better way to go about it if the site can accommodate. If there's some kind of median, and if you're able to extend, if there's space to extend the drive aisles, so this really pushes those parking spots clear of the foundations, but it would then need some more space for drive aisles in between the lanes, but this is a different approach. And then lastly, if there is some kind of median or bioswale or something like that, then you don't have to work with necessarily, you don't have to work with the parking lot line spacing. You can space out the foundations to whatever your heart or the design desires. Although I will sort of call back to the clearance, the 5-meter clearance for fire lane separation. So if you're pulling into a parking spot that has a frame kind of like directly in front of you, that can be a challenge for frame designs that have angled members. Again, depending on the model and the geometry of the carport itself, this can be a consideration. So then, those images are all showing large rectangular precast foundations. That's what we tend to do, but there are different approaches and treatment types: pour in place, caisson, either raised or submerged relative to grade. Some choose to make the foundations more a feature by adding a skirt, like the image on the left. These are some more examples of different options for resolving elegantly, I guess, or not elegantly, depending on how you feel about these structures, but resolving that connection point between the structure itself and the ground. So you see, different applications of that in that sort of call back to the examples that I was giving. This is the most recent picture. This was taken on a roof of a site yesterday in Cambridge for a carport that we're installing, that we designed, constructed, and are in the process of constructing. But we use precast concrete foundations and integrate. It allows us to integrate electrical conduit at the point of manufacturing. And then we can cap them if we don't use them, but it's handy to have those integrated into the concrete from the get-go to facilitate cable routing and eliminate the need for concrete curing time on site. So there's different approaches and they have different advantages and drawbacks. But this one is quite live. I think we have a crew there live right now working on. This is one array of 3 in a long 13 foundation canopy in Cambridge. A couple more slides here, and then we're on to kind of wrap up and get to questions. So other Ontario Building Code and local bylaw considerations to think of. Again, we could do multiple sessions on this, and we were really just skimming, but some other things that feel relevant at this stage. So site plan control as governed by the Planning Act. So some carport projects that sort of add structures over parking lots will trigger full site plan approval. So you have to coordinate with grading and drainage and civil sewer, that kind of thing, landscaping, traffic circulation, all of these kinds of aspects, depending on how they're deemed. So I put in quotations here, sometimes these are called parking structures or buildings or accessory buildings or ground mount solar, and they all have implications for occupancy and fire separation and suppression or sprinklering, that kind of thing. So we prefer that they are, and we've sort of like charted a course that they are deemed a building. It does mean that a building permit is required when building these. So that means that you need structural drawings sealed by a professional engineer. and then again, like local sort of municipal or each municipality will sort of reference the building code for enacting or for building these structures. When it's not deemed a building, and this is kind of why we don't like going this route, a canopy is assumed to be some sort of ground-mounted solar installation. You would see those in sort of either farmers' fields or big utility scale projects. But then they're subject to a kind of whole different range of environmental studies and regulations. The two, for smaller projects, it's called an EASR, Environmental Activity and Sector Registry, for projects between 10 kilowatts and 500, or with I should say, each transformer is less than or equal to 750 kVA. For bigger projects, you would get into a renewable energy approval, so an REA application and process. So that's 500 kilowatt systems and above. And then you know that is quite a lengthy and detailed process. You have to do sound studies of the impacts of the inverters and the buzz that they kick off, and those kinds of things. So they're quite extensive. But we think that these are architecture and that they are buildings, and we've had luck going that direction. I talked a lot about sort of clearances above parking spaces. So I won't really go into any more of that in the interest of time, but you also want to think about kind of like illumination and signage, and different municipalities have different rules about light levels to different degrees of detail, I would say, depending on whether it's a public space or private property or that kind of thing. And maybe lastly, as Brian said, these are these are power plants. These are there's a lot of live electronics, electrical equipment that are part of these. So ESA permit and working with the Ontario Electrical Safety Code are important aspects of this work. You have this kind of DC cable management. So on the DC power production side, every PV panel is connected to each other in strings, as Brian talked about. Multiple strings have capped voltages and they feed into an inverter. There's bonding and grounding required. These are metal structures, so definitely want to be intentional about that. And then after the inverter, converting that power from DC to AC, the inverters have to be mounted within 1 meter of the array, so kind of nested up quite close to the array. Otherwise, some technology called rapid shutdown protection is required to be installed, and we've done that on some, but really like to avoid it. I would imagine that other carport providers would say the same. The inverter is then connected to a combiner, junction boxes and disconnects, and all of this. Really, the point of highlighting these at such a high level, communications cables, lighting power cables, EV charging integration, is that there's no walls or floors or ceilings to neatly and discreetly hide all of this. So how and to what extent these are considered in the design can either allow people to focus on the aesthetics and the kind of architectural wow of the structure itself, of the solar canopy itself, or they really detract from the impact that these structures can have when they are executed with more intention and that sort of a systems approach. And yeah, here's just a couple of examples of on the electrical side what that can look like. So cable ties with the red, but these are really sitting at the bottom in a trough where water is trickling down on this particular canopy. So kind of half a thought, but not fully resolved here, I would say. In the top right there, the cables are bundled, but they, it's impossible to hide it all, but you can do it elegantly by kind of using tech cable and conduit and trying to manage that and resolve that in as clean a way as possible to make sure that all that power is safely transmitted back to the building and eventually the grid. So that really wraps things up. But key takeaways, I guess, if you were to remember 5 things from what we've shared today. Solar carports are more than power plants. They shape space, they provide comfort, and they contribute to design expression of otherwise underutilized kind of flat, necessary evil surfaces. Number 2, think local. So sun angle, snow, ice, corrosion, and codes require really context-specific solutions, not even just in Ontario, but in specific geographies within Ontario. Thirdly, typologies and form factors matter. So cantilever, mono and dual slope, modular, foundation choice. Each of these have distinct implications for site planning, for generation potential, therefore for ROI and payback, for user experience. All of these aspects change significantly, whether you go from a monoslope to an east-west kind of dual slope, that kind of thing. Early coordination is critical, which is why we're so thrilled to have been invited to a conversation like this. Coordination with architects and engineers, electrical teams, planners, bylaw folks, all of those things is critical, and you need good alignment from the start. And lastly, design for tomorrow. So integration of EV charging, battery, if that makes sense, especially if you're starting to deal with like smart grids that can time when they're releasing that energy to the grid. So battery integration, grid integration, appropriate material choice, all of these things ensure long-term resilience and continued appropriateness, I guess, or applicability of these structures, so they don't become sort of architectural relics, I guess, or just pieces of visual infrastructure that aren't producing the way they could long into the future. So that's everything that we have for you. Happy to dive into some questions, and we hope we've sort of lit your minds on fire a little bit with some areas of the world that we focus on every day, but maybe you don't.
Fantastic presentation. We already have a bunch of questions, so I'm just going to get right into the Q&A portion. And for those of you on the call, if you wanted to continue asking questions, we'll try to get through as many as possible. But yeah, I think definitely some very specific questions, a lot of engagement, and a lot of fantastic information. The first one came in right away, so you may have already addressed it, but I don't think so. So the question from Scott, you'll probably have addressed this, he's saying, but my understanding is that sun tracking is now not a technology that has a reasonable ROI. Is that true?
Yeah, so that's where we started as a company, was with the trackers. And
Yeah.
why we started in trackers at the time was simply a function of the cost of what a panel was selling for. When we were buying panels initially, we think in dollars per watt of generating capacity. So the first panels that we were purchasing were right around the $4 per watt price range. I know that won't mean much to you, but now we're buying panels for 95% less than that price. And so, the answer has largely shifted to panels are so cheap now, just buy more panels, install more panels, rather than add the complexity of moving parts, control systems, motors. Having installed hundreds of trackers, this is one of those things that if we had it to do over again and we could get panels at the price then that we can now, I think we might have never installed a tracker and just gone with fixed systems.
Good to know. Okay, next question. How do you promote / justify the integration of solar panels / canopies for potential projects where clients don't perceive solar panels as necessary?
Yeah, I'll start. I mean,
Sure.
so I started in business development here at VCT. So a lot of my job before was promoting solar canopies and solar. I think really it's important to align with the values and how that individual or that company is coming at it. I think to me, some people it is all about accounting. The math has to make sense. We've got, we need financial return of a payback of 5 years or less. Can you make it work? And working within those constraints. And so then you take that track to sort of convince or to show the how solar can hit those targets. I think the interesting thing for me about canopies, and then I'll curious to hear what Brian says, is that for rooftop solar, it is largely out of sight and out of mind. It is invisible. It's largely a sort of like transactional piece of equipment on the roof. A solar canopy kind of allows you to it makes sustainability visible. So then values alignment with ESG goals or with corporate sustainability targets this creates a visible commitment to that in and around a customer's building. So I like those two kind of angles. But Brian, curious to hear what you say.
Yeah, I'm not sure much would need to be added. I mean, something that we lament a bit as a company in this industry is that at some level, solar is a luxury purchase. People can get their electricity from the grid just fine. You know, is there something that absolutely requires a person to integrate solar in their site? Right now, there really isn't anything that pushes a person. So if they want to maintain the simplicity of what they've got for a building, you know, we really can't push them too far the other direction, and there are plenty of opportunities for us to be installing on other sites.
Maybe just to add on to that, but even just knowing about net metering and how the power, the electricity from these systems are monetized in our local grid in Ontario can really just change the conversation from being a nice to have to a wait a second, we can pay this off in 5 or 6 or 7 years and then not pay for electricity moving forward, not have an electricity bill. That really changes the nature of the conversations for install.
Yeah, I imagine so. It's just getting that information and having the proof of concept.
What is starting to drive people to potentially need solar or on-site generation a little bit more is if you dive into the scope language around emissions, scope 1, scope 2, scope 3. And so some of the conversations that are coming to us are producers of, you know, we'll use an example, producers of food in the grocery industry. So the grocery stores themselves, when they buy a product from a farmer, let's say, and put that product on their shelf, whatever embodied carbon, embodied energy is been consumed in producing that product and getting it to the shelf, that becomes a scope 3 emission for that grocery retailer. And more, the grocery retailers are saying, hey, I don't want you contributing to my carbon footprint. So you need to deliver that product or that service to me without any carbon in it. And so that's where we are starting to see more and more people invest in solar, invest in renewable technologies, sustainable technologies, just to reduce the amount of embodied carbon, embodied energy in their product and service as they're passing it along their supply chain.
Okay, great. Yeah, a bunch more questions, so I want to make sure that we're getting through these in a reasonable pace. So the next one's very pragmatic. It's a really good question from Trevor, who wants to know, with the conversation of shading and performance, do the solar panels need to be washed due to dirt and scum? And if so, how often do they need to be washed?
Absolutely, in some areas of the world, it is a major issue, soiling and cleaning the panels. Here in southwestern Ontario, in most seasons, we get enough rainfall and it's clean enough rain that most of the cleaning is done just through that process. You know, sometimes if you've got a lot of detritus, you know, sometimes a flock of birds moves through and they can really soil a system. Every once in a while, it does seem to be worthwhile to get up there with. There's now, you know, scrubbing robots that you can do remote control of a system to scrub along and wash along a panel. Again, for the most part in Ontario, though, just the rainwater is going to do a good job. If you are on a site where there's some type of manufacturing that's releasing something else into the atmosphere, then it does become more of a consideration. So sometimes on farms, if these are near, you know, say corn loading or unloading, and you get that starchy dust in the air, sometimes that adheres to a panel a little bit more. Sometimes there's, you know, exhaling paint, you know, what's the spray room exhaust does sometimes direct towards certain areas. And if that starts to adhere to a panel, then it's going to take a little bit more of a solvent and a scrub. When it comes down to, we were in Las Vegas last week for the largest solar show in North America, and they hardly get any rain. And so they do need to get out there and wash their panels pretty frequently in order to keep those systems performing.
Okay, great. Scott's asking, I've had difficulty with Ontario Hydro in terms of what they say the local grid can accommodate. My understanding is they're being very conservative in what they estimate the grid can manage. And OH
Ontario
is
Hydro.
getting better. Yeah, sorry, Ontario Hydro. I was like, oh, no, it's Ontario Hydro is getting better in the approvals process. Are they learning more about their actual capacity based on actual evidence rather than inferences? Is this being translated into an easier and more forgiving process?
This is something that we share the frustration. You're not wrong that at times it does seem that the calculations they apply to say what are they going to allow onto the grid are somewhat arbitrary. At one point it was called the 7% rule. They don't want more than 7% of the energy transferring on any of their lines to be coming from distributed generation. That has changed a few times over the years and generally been bumped up, and it has been mostly just from, again, a very high level of conservancy rather than from truly pushing towards the end of the edge of the envelope to what they could actually accommodate. Things are moving in general in the right direction, albeit slowly. Something that just actually was released not too long ago is that there is now on the Hydro One website a geomatics or a mapping system that you can actually look to see fairly real-time mapping of where are areas of the grid constrained, where are their connection capacities available. There's a link to that we can probably share one way or another, or I think a Google search might reveal that as well. So there is more and more information becoming available. Hydro One is the largest LDC by LDC, we call them local distribution company by geography. So a lot of the rural areas and small towns are covered by Hydro One, but there's about 60 some utilities in general, and more of them are releasing those maps that show where can you or where can't you look to connect systems.
Okay, great. The next one is just about discussing construction costs. You might have already mentioned it too about steel versus timber. But is there a big distinction between steel and timber in terms of the cost?
We didn't actually touch much on specific costs, just very general indications. We would mostly be talking from our own experience on that, and I did briefly say that we recognize pretty significant economies of scale. So if you're looking to put a carport or canopy over just 2, 3, 4 cars, again, we talk and think in dollars per watt, but we can translate this into dollars per square foot with a bit of time. So on a dollars per watt basis, a canopy over a few cars is going to be somewhere in around the $10 per watt range. If we can get to a massive parking lot, we can probably even be under $4 a watt at grand scale. And so you can get a sense of just how much more cost effective it is when you're doing a large scale versus a small scale implementation. I think that's probably the best I could do in the moment here. We'd have to get into more specifics if you're looking for a little more detail.
I think the other thing to consider there, I touched on it briefly, but not with any sort of like specific comparisons, but are you talking about sort of upfront cost or total cost of ownership? Because I think those are different conversations, especially when part of like this is infrastructure that pays for itself. So over time, it will generate the electricity that you feed back to the grid and get credits on your bill. So there's some context there about cost for sure.
The next one's about snow. So do you have any examples of carports with snow cleats to prevent the ice / snow sheets dumping off the roof? And are there any other maintenance considerations when you're adding those snow cleats?
Yeah, so we actually we just designed sort of a feature or an additional fixture that can go on, that can kind of bolt on to one of the rail channels. The snow guard, we've sort of designed it to have a bit of flexibility, so you can either install it just as a tooth and you can install multiple teeth along the edge to break up the snow. But the edge of that clip kind of has a C so that you could insert like a large bar, and that it's amenable to different locally available sort of like inch diameter steel bar or aluminum tube or whatever the case may be. So yes, we've just designed our own, and we're actually, that if you can hear any cutting in the background, and apologies for that, it's because we are cutting them right as we speak. There are other sort of like, I would say, tack on or products out there in the market that largely come from regular sort of roofing industry. But that's our approach to it. I forget the second part of the question. Other maintenance considerations, maybe, was it?
Yeah, maintenance, no, sorry. Yes, maintenance for when you're adding the snow cleats. Does it add to any maintenance that not having them?
Well, I'll jump in a little bit and answer that in with a little bit of extra information as well. So we feel that there's two different strategies in managing snow. So the first strategy, which I think this really leads towards, is that tooth or that cleat where you're really trying to just break up the snow, still have it fall off, we'll call it, or shed from the array, but come down in small and relatively safe chunks or amounts. The other strategy is to really just hold all of the snow up there until it melts off. And so that's some of the different geometries that we were showing, whether we have that vertex design, that trough in the middle, which really goes after that, hold the snow and just don't let it ever fall off. And that's our lowest liability design or geometry that we would go after. But then anytime you're holding snow up, it's also opportunity to hold other things like leaves and branches, all the kinds of things that can get blown around a parking lot. So yes, as you would add things that hold up snow, that's also going to hold up other things. And it is going to potentially require a little bit of a maintenance and cleaning cycle to it. And I did see down on the list, how do you address the issue of birds and nesting? It's really that same kind of a thing. Every crook, every angle can become a nesting opportunity. Right under the panels, it does get really quite hot. So it's not the most hospitable environment there, but we still do find willing wildlife to find some homes in these kind of things. So really it's just a periodic inspection and looking for these things before they become an issue. Most of the time it's an aesthetic issue. If it is right at the panel and it's a nest, then sometimes it can actually become a safety issue. If you've got really hot cables, hot panels, I guess it's the panels more than the cables. But we do also have squirrels that enjoy chewing on cables from time to time, and then that can cause some problems as well.
Yeah, and there was another question in the whole maintenance. What about water runoff management? Is that an issue?
It can be on a site, so depending on where the eaves of a carport may be, if you've got that monoslope all tipping towards one edge, again, if we go back to the geometries, we're speaking mostly from our own experience of designing and building these. If you look at that monoslope, putting an eaves trough in the front is certainly possible, but then trying to manage a downspout to elegantly bring that water down to grade, you're sort of left with a dangling downspout out in space there. And so from a quality, from a longevity, from an aesthetic standpoint, we don't think it's ideal. And so that's where the hybrid, the check mark, as Patrick called it, or sometimes people say we should be calling that the hockey stick, that does allow for that trough to be more integrated within the array, and then the water handling can be more functionally brought down to grade and dumped there. Or we're actually on one site, we're actually taking it below grade and then putting it directly into stormwater. So yeah, it's definitely an issue to consider. How are we handling the water runoff?
Kathleen is asking, are there any integrated options for water curtains / fire suppression when a carport is beside another building and has a limit on unprotected openings? Very specific questions. I don't know if it's,
we are in conversations around this topic, but this is learning for us as well as to really what triggers us needing to employ certain strategies here. If we look at the largely metal systems that we're building, sometimes we're doing calculations, and we've actually put together some reports of what's the kilograms of combustible material per meter squared, and it is very, very low within a solar carport, at least the ones that we're typically working with. And so sometimes just by showing them that, where it's less than a kilogram per meter squared, sometimes we're able to avoid that sprinklering conversation. But on one site that we're at, we just haven't been able to work around that setback, and so we had to actually shift the row of cars over by about 80 centimeters on a site just so that we could get that separation of the carport from the building. So I wish I had a better answer for you.
Yeah, no, there's so many questions coming in, and I'm just going to make a point that we might not get to all of them, and some of them are really specific. So maybe there's an opportunity to reach out directly, but I'll try to get through a few more before we have to sign off. There's a good question from Celine about the green roof standards. I know we actually have a webinar and cross promote that coming up about the Toronto Green Roof Initiative. but is there any like intersection with those initiatives or standards, or is that something separate?
So green roof would at least from what I'm going to interpret this to be is essentially having some sort of a grass and soil surface on the roof of the building. Generally, that's not something that we ever try to integrate with a solar canopy. When it comes to more typical rooftop solar, then it is something that can coexist. But honestly, we shy away from putting solar on top of a green roof. One of the things is that solar and organics, it isn't ideal to mix them in our experience. You do get mosses and lichens building up on the panels, and it can be a little bit difficult to keep the panels clean. And then from the rodent factor, a lot of wildlife does make the green roof its home, which is a great thing in and of itself. But keeping the rodents away from the wires and everything like that is generally our strategy. And so mixing them doesn't always go well, but there isn't anything per se that would say that you shouldn't ever mix rooftop solar and green roof.
Okay, that's good to think about. Catherine is asking if there's a certain size that justifies the cost. Is there sort of like a threshold that you found where it makes sense financially?
In our experience, what we've often found is that as much as there's a lot of altruism behind this, if the economics aren't there, these projects largely don't go ahead. And oftentimes, once we get under that 10-year payback or around that 9 or 10% return on investment, that's where they do start to become attractive. For the most part, with solar canopies, if you're only looking at that energy value, you're probably still going to be challenged on trying to get to those numbers. There are several grants that are available in the province. Well, one of them is federal. There's the investment tax credit for tax-paying corporations that can take 30% off of the total cost of a system. And the whole carport, including its foundations, does qualify for that. Provincially, if you go with a modification of that net meter model to say that I'm never going to let surplus energy go up to the grid, they call that load displacement. There's a provincial save-on program that can cover half the cost of a system up to 86 cents a watt. So I guess in the carport context, it's probably more like a quarter of the cost of a carport. And so those will certainly help, and you can bring it probably into the low double digits, maybe 12 or 13 years out of those alone with the energy value. But it's really some of those, what I was referring to as the stacking benefits. So if there's snow clearing savings, if there's EV charging infrastructure savings that you can attribute it to it, if you're in a place that you have the ability to charge for that improved parking amenity, those kinds of things are what can really bring that payback down and really make it financially lucrative into that 6, 5, 4-year payback potentially as well.
And do you see these carports applied in residential, like for a single family home or in a smaller scale? Is this something you've worked with, or is it primarily commercial?
For us, primarily commercial. I mean, there's from a structural perspective, there's nothing stopping it. From an economics perspective, as Brian was saying, the economies of scale aren't really there. However, in our or our sort of approach to that, I guess, is to say, if a homeowner were to build, let's say, a pergola or like a timber cover, we can modify our racking to transition from whatever material they build that small structure, and then just get the watertight kind of canopy on top. It's kind of this mixture, between a carport or a gazebo, some kind of canopy structure, rather than us, because then you're shedding a lot of the material of the structural elements, and you're getting the kind of solar and water handling value, and so we've seen some uptake of that in pockets.
I'm just going to kind of wrap up with a couple of questions. There seems to be a few around costing, and I know it's going to depend on so many things, but are you able to sort of ballpark for like a single stall what that would cost? Or, if it's too complex, in terms of materials.
Well, for very quick rules of thumb, with the ever increasing efficiency of panels, a general guideline is that we can get about 5 kilowatts of solar over an individual parking spot. And so then when we apply that dollars per watt, so 5 kilowatts is 5,000 watts. And so if we're doing a single parking stall, then we are probably more towards that $10 per watt, and we really are almost at that scale of $50,000 per parking spot if we're only doing 2 or 3. If we're doing a much larger parking lot, then that $4 per watt times 5,000 watts would be about $20,000 per stall in that larger, more economies of scale being achieved lens there.
Mhm.
I do see one on site plan application. I'll just throw a quick answer to. It is very much as to who you happen to be working with at the building department, but what we have seen a little bit of success on is really convincing who you're working with that us putting this in the parking lot, as much as we call this a building, doesn't really meet the grade of developing the property. So if you can convince them of that language that this doesn't count as developing the property, sometimes you're able to avoid that site plan application.
Great tip. Oh my goodness. So much good information. And I think we could probably keep you for at least another hour with our audience. But unfortunately, we are at time. And I have just a couple of closing announcements before we sign off today. Clearly, this was a really informative presentation with a great discussion started. So I think our members will take a lot of valuable information. So thank you, Patrick and Brian, so much. I just wanted to remind everybody who's still on the call that we have a webinar next week on the Masterpiece Development Infill Heritage. We've also got some really good offerings for the fall, including a couple that are on professional regulation and ethical conduct. And I would encourage you, those are at 50%. So please do look at the offerings coming up in the fall. We are approaching an end of cycle year, meaning that everybody's got to get their hours in by next June. So it's a good time to plan ahead and book a few webinars and get that out of the way. As I mentioned, will we be reporting these hours and accrediting your time for those of you who have been here for 80% of the webinar. I also really encourage people to fill out the survey that you'll get. We'll also send, as Brian and Patrick mentioned, we'll send a PDF of the slides. And so let us know. I'm also curious, will you be, using this information for your clients to encourage them to engage in this? I think it's a really, with this more information, there might be a stronger business case to be made. So I think that's a really good thing that we'd love to know. And yeah, so everybody please have a wonderful remainder of the day. It's a gorgeous sunny day outside here in Ontario, at least if you're calling in. And thank you again, Patrick and Brian. Take care.
Thank you.
Thanks, everyone.